Hey guys, what's going on? It's Adam the Science Tutor. Today we're going to be talking about redox potential. It's abbreviated by E, and we could usually find this in a table with, and it's E0, the theoretical value. So it's useful to find spontaneity or non-spontaneous reactions. It's kind of similar in helping us find spontaneous with like negative delta G. That's usually the more common form, but redox potential helps us as well. So it also helps us find a good oxidizing agent versus a bad oxidizing agent or a reducing agent. So an oxidizing agent or a good oxidizing agent is one with a positive E0 or E redox potential. So if it's positive, it shows us spontaneity and it shows us oxidizing agent. So it's very important. So as I'm writing here, E0 shows spontaneous and a good oxidizing agent. So yeah, let's see. Very cool. And let's get down to the nitty-gritty stuff. And some of this may be confusing, but just a lot of memorization. So redox potential, you've all probably heard of it. There's oxidation and reduction. I like to use oil rig. Oil for oxidizing is loss of electron. Reduction is for rig. Reduction is gain of electron. And I know this is a confusing idea, but the best way to think of it is reducing. So electron carries a negative charge. So if you're gaining a negative, you're therefore being reduced. So that's the best way I feel like you can remember this. So oil, rig, oil, oxidizing is a loss of electron, so therefore it's getting more positive. Reduction is the gain of electron, and therefore it's going to get more negative. So I'm writing this down in notes so that you guys could take notes. As always, I feel like for every video, you should write your own notes and make something for yourself, like a study guide or just notes on the side. So again, think of reduction as gaining more negative charge, so more electrons, and it's being reduced. So that's reduction. Now we're going to go into the agents. So I know I said a positive redox potential would signal a good oxidizing agent. An oxidizing agent is a molecule being reduced. So a molecule being reduced is a good oxidizing agent. And I know that's confusing, but it's just flipped. And then a molecule being oxidized would be a good reducing agent. So a reducing agent is being oxidized, and an oxidizing agent is being reduced. And I'm going to give you guys an example here, and I'm going to give you guys some problems to work out as well. So yeah, there that is. Let's see when I scroll down. Highlighted, reduced for oxidizing agent, oxidized for reduced agent. So let's look at a little example. It's not going to be any real molecules, but so if B were to pass 2 electrons and two air in the form of hydrogens to molecule A, so B plus A plus 2 electrons or 2 hydrogens. Taking a bit of time here. Yeah, B plus A plus 2 hydrogens. And B's giving him this, so B's gaining the hydrogens, and then A is going to gain the electrons. So which one's which? So B just gained hydrogens. A gained a 2+ charge, so it's almost as if it lost electrons. So if it lost electrons, it would be a oil. So oil is for oxidized, so A plus 2 would be oxidized. BH2 just gained hydrogen and the electrons, therefore it is being reduced because rig is the gain of electrons. So which one's which? So if BH2 is being reduced and A plus 2 is being oxidized, that means B would be the oxidizing agent and A would be the reducing agent. So therefore A plus 2 just got oxidized, and BH2 just got reduced. So A would be the reducing agent. And once again, I know it's confusing, but the molecule that's being reduced is the oxidizing agent. So think of it as a gain. A plus 2 is a gain. I mean, no, my bad. A plus 2 was a loss of electron, and BH2 was a gain, so oil rig. So it's being reduced, therefore it is the oxidizing agent. Cool. So now let's do a little bit more serious of a problem. So usually the E0 is a theoretical. It's usually found in a table, and it's given to us majority of the problems. The only time it won't be given to you is if they give you the same reaction, and we must flip it to find the redox potential. So this is a very popular reaction, and it happens a lot in electron transport chain. So NADH to NAD plus hydrogen plus 2 electrons equals a positive 0.32 volts. So it's in volts. Volts comes from the Ohm's law. Ohm's law is volts equals current times resistance. But I wouldn't worry about that. It's just in volts. Just remember it's in volts, which is a way we could calculate the amount of energy or electrons, pretty much. So which is which, and what is the E0 in the bottom reaction? So let's figure out which one's an oxidizing agent and which one's a reducing agent first. So, and the positive E0 already shows us something, or gives us a cue. Since I said positive E0 shows a good oxidizing agent, that might be an oxidizing agent. We just gained 2 electrons, so that means NADH was reduced, therefore it's NAD plus is the oxidizing agent, NADH is the reducing agent, and excuse me, NAD plus was reduced. Therefore NAD plus is the oxidizing agent. NADH was oxidized and therefore is the reducing agent. So to find the other voltage, I told you guys before in the beginning, if you're not going to change the number, you're going to change the sign. So the number wouldn't change. We flipped the reaction, and therefore it is flipping the sign from positive to negative, and our total voltage would be a 0. So and that makes sense because I gave you guys the same equation, and they're canceling out. So it would be negative 0.32, not spontaneous. So the voltage total would be 0. And it'd be a bad oxidizing agent because NADH is a reducing agent. So let's carry on and look at another equation and another different way your teacher may give you a question. So NAD plus is an oxidizing agent, just like over there, and NADH is a reducing agent, which it shows us with the E0 or redox potential voltage amount. I'm reiterating the positive thing, so it's very easy, very cool. If you are able to tell what E0 is, it shows you spontaneity and a good oxidizing agent versus a bad oxidizing agent or reducing agent. So let's draw another little thing. So E0, and this time I'm going to give you guys an equation that we can typically find in electron transport chain in complex 4. So it's going to be kind of fun, kind of cool, more relating to the body, but it's kind of cool. So the same way, NADH to NAD plus hydrogen plus 2 electrons, and we already know that is going to be a positive E0, 0.32 volts. We're going to take water, H2O, to 2 hydrogens plus half an oxygen, because of O2, so it's 1 oxygen, and 2 electrons. So we're going to look at the E0 values, and it's always important to get these values from a table because they show you a lot, and your teacher will have to give you 1. So we have a positive 0.32 volts, and look at that, we have a negative 0.82 volts, and I know what you're saying. I know you see the 2 electrons, and that's just the way the reaction works, and that's the way the E0 is calculated for water. So right now the total would be 0.5, negative 0.5. Therefore, it would not be spontaneous. It would be not good for our body. So therefore, how would we change this to make it spontaneous? If your professor had said, how do I make this spontaneous? What would you do to which reaction? Well, we want to change the sign. So in order to change the sign, we're going to have to flip the reaction for water. And 0.82, if we make that positive, that would be a great oxidizing agent. So we flip the reaction, and I'm going to have to erase that to make more room, because we're having 2 hydrogens plus 2 electrons plus half an O2 to make 1 oxygen, because there's only 1 oxygen in water. And then we need to flip the sign, so now it's 0.82 positive volts. Add these two up together to get our total, which would be 1.14 volts, positive 1.14 volts, which makes it a great oxidizing agent and it's very spontaneous. And this is what your body's going to do in the electron transport chain to get good oxidizing agents and get the most amount of electrons that we can in complex 4, where we have NADH and we have our water molecule. And I'm going to talk about why it's important, and that's what I was saying. In the body, we're going to need things to be spontaneous, where we want reactions to occur, and we also sometimes want a slow reaction, so we won't want them spontaneous. We want to hold off on them. So how we do that is flipping which things are going from what to what, and where our better reducing agents should be and where our better oxidizing agents should be. So that pretty much sums it up. I'm going to give you guys a little bit extra little informations, but thank you all for tuning in. Please subscribe and enjoy the rest of the video. I think I'm just going to go over a few more notes, but if you guys have any questions, please email me below. Thanks. Have a good one.